I do want to make sure that if you look at the table, that you know that slow twitch, high oxidative fibers are shown here, or otherwise known as type 1. Slow twitch, high oxidative fibers are here, or type 1 fibers. Anything that is fast twitch is then usually referred to as a type 2 fiber. And then this would be type 2A, and this would be type 2B. Type 2B is fast twitch, glycolytic. This is the kind that is a sprinting type or a fast movement type of muscle. Type 2B, if you're keeping track. Okay? And this one is called type 2A, in that is a fast twitch type muscle, but it is primarily an oxidative muscle. It can do a little bit of anaerobic, but it tends to prefer doing aerobic. Okay? All right? As you move on down, then you start to see some of the characteristics. Speed of contraction, we've already got down pretty well. Myosin ATPase activity. What does this mean? You're scientists now. ATPase is an enzyme that breaks down ATP. Myosin is the myofilament, which is in the center of the sarcomere. The hinge region of myosin that we've learned is an ATPase enzyme can be of two types. It can be of a type that is slow to break down ATP, and therefore slow to make cross bridges and break them, slow to twitch, or it can be a type of myosin that is fast to break down ATP. And that's where we get our type 1s and type 2s as to which kind of myosin they incorporate. We can see here, primary pathway for ATP synthesis. This is an aerobic muscle. This one is aerobic, but can switch. That's why it can be a fast twitch type of oxidative muscle. If we go on down here, we see myoglobin, what gives muscle its red color, high levels, and then low levels. So, muscles that tend to use oxygen will incorporate more myoglobin. Muscles that don't will be lighter in color and have low myosin concentration. Glycogen, again, this is a muscle that is not all that keen on using glucose for metabolism, so it tends to be low in glycogen, but then this one favors glucose, tends to be high in glycogen. Recruitment order, this is a little different. What this line is saying is, your brain will activate the slow oxidative fibers first, unless it needs more speed, and then it will recruit in the fast twitch fibers. So it starts an activity with a slow twitch fiber, but if that isn't sufficient, it'll recruit in high twitch fibers, or fast twitch fibers, and you'll get the control that you need. Rate of fatigue, we've got this one. This is a slow to fatigue type muscle, okay? Postural muscles, at the end of the day, should probably not be sore or have lactic acid buildup. They probably have had enough oxygen to keep them running all day. But sprinting muscles fatigue fast, okay? And we can go on down the line. This is a good table, okay? Good table. I guess the last thing that's sort of interesting here is color, and then the number of mitochondria. Let's end with that, okay? See if your thinking caps are on. It says slow oxidative fibers have a lot of mitochondria, but fast glycolytic fibers have few. Why? Tell me why. That's a good test question. Maybe we should throw one out and put this in. Why is it?
Tell me out, that's what you do.
Why is it that fast glycolytic fibers have few mitochondria in the cell? Yes?
Because they don't do aerobic respiration, which is what mitochondria are for.
Do you believe this guy? Do you believe him? He hit it. He nailed it. Okay? He reminds me of Jim Ignatowski. Anyone know Jim Ignatowski? Look it up. Okay. Mitochondria are needed for aerobic cellular respiration. Glycolysis does not occur in mitochondria. It occurs in cytoplasm. So a cell that is doing glycolysis doesn't need a lot of mitochondria, okay? But a cell that is doing a lot of Aerobic respiration needs the mitochondrial membranes in order to make that happen. This is where we start to separate the non-scientists from the scientists. When you start to recognize the role of mitochondria and the fact that they have to be there if the cell is doing aerobic metabolism, okay? Okay then, I believe that was chapter 9. Now we're gonna go, I believe it's chapter 11. I'm sorry, what? Oh, okay. Right, okay, yeah, so you and I, we know this, don't we? Jim Ignatowski.
Oh, so that was kind of
It's a good thing.
okay.
You'll like Jim.
I thought it was disguised as a compliment.
It is. It is. He was a fun guy.